Hey guys, welcome back. Now I will be introducing another magnetic sensor, that is MMC3316xMT. Now to gain more knowledge about this sensor, let's have a look over the website, that is controleverything.com, and here search on for this sensor, that is MMC3316xMT. As you can know, you can see clearly that it's a plus minus 16 Gauss 3-axis magnetic sensor, and these are some of its features which you can notice on the screen also. Also, you can have the opportunity to purchase the sensor from this very site, right from here. Well, I will be interfacing the magnetic sensor MMC3316xMT with a particle photon, and I will be requiring a code. So go to the resource tab, and here comes the particle code sample of MMC3316xMT. Now you can download the code as a zip file from this website. Also, you can get the code from github.com, and the repository there is Control Everything Community. Well, let's have a look over the hardware connections we need to work out this sensor in this video. Let's have it. Now, in the connection segment, first of all, the requirement is of a particle photon, which you are able to see on my screen, and this here is an I2C Shield. It's very useful in making connections with other I2C devices, and that's why we use it, and it's available on the website controleverything.com. Now gently place over the particle photon over the I2C Shield and make a connection. The next part is to provide the magnetic sensor, that is MMC3316xMT, and this here is a connecting cable. Now make a connection among the sensor and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and same goes for the I2C Shield. Now the last part is to provide the power, so we need a micro USB cable just like this, and gently insert it over the power jack, and we can have the power. So we are done with the connections part. Now what do we require is to have a look over the code. So let's have it. For the interfacing regarding the particle photon and the particle code, and to achieve that, here we have to log into github.com, and here we have to search for the repository, that is Control Everything Community, which you are able to see on my screen, and click here, and hence search for the sensor, that is MMC3316xMT. Now this is the particle code we would like to explore, but before that, let's have a look over the particle photon applications. As you can see, the instructions basically. So it says that we have to log into our particle photon and set up the device according to the instructions being provided on this link. Please have a better view regarding this link so that you can achieve the relevant information or familiarize yourselves with the information of installation and setup the device. So note it down. Now the next step is to download or git pull the code and go to the online ID and copy the code there, and build.particle is the perfect link for that purpose. As you can see here, we can have the output, the code output will be there, and after that save it the code, and after that we have to verify and flash the code on the particle photon, and the code output after verify and flashing, the code output will be in the form of logs at dashboard, and dashboard.particle IO, the user logs will be there for the relevant magnet data output. Yeah, that's correct. Now let's proceed back to the particle code. It says that it's a .in extension file. As you notice in the code, we have included the header files like application.h and spark wiring I2C.h, and we have defined the address of the sensor, that is 0x30. We have initialized some of the variables here. Similarly, some here we have initialized I2C communication as master and serial communication with the baud rate equal to 9600. Then in the writing part, we have selected control register having address 0x07, and the command we are sending here is to initiate measurement, continuous mode, and coil set, which is 0x23. Next, we are selecting the control register having address 0x07, and the command sending here is coil not set, which is 0x00. The last command to write is to select the control register 0 having address 0x07, and we are sending the command to initiate measurement, continuous mode, coil reset, that is 0x43. So we are done with the writing commands. Now we want to get the data back, which is in the form of reading data, and we have selected the magnetometer data register having address 0x00, and from this very register we are requesting and reading 6 bytes of magnetic field data, which is the perpendicular axis x, y, and z. And after that, we have the conversion of the data takes place, which is according to the information described clearly in the data sheet for MMC3316xMT. At the very end of our code, after so much of calculations, we have the output be displayed on the dashboard, which is the magnetic field in X, Y, and Z axis. Let me mention you, these are the raw values. It can be negative, can be positive, depends upon the at that time present magnetic field. So note that this point carefully. Now what do we need is to show the practicality of this code. So let's have it. Now for the working environment, first of all we have to copy this entire code of the particle as you can see on my screen. Now here open up the build terminal as we have discussed earlier, and here create a new file which we have copied just like that, and we have to rename the file. As you can see, it's MMC3316xMT, and here paste the entire code as you can see, and then save the firmware. Now verify and compile the code as you can see on my screen, and then flash the code. While flashing the code, we have to check for the magenta flash, which will confirm that code is good to go and we can have our output displayed on the screen. Yes, that's just now we have the magenta flash on the particle photon, and the successful notification of the flash is at the screen like here. Now what do we need is to open up the dashboard user logs link we have discussed, and here we can have the output displayed on the screen. As you can notice, we have the magnetic field in X, Y, and Z axis, and it's almost constant. But when I bring a bar magnet near the sensor, you can see the changes in the magnetic field for all the three perpendicular axes, that is X, Y, and Z. Yeah, just like that, the values are changing. So this is how the sensor works. Now what we require is to show the benefits, applications, and the features of this magnetic sensor, that is MMC3316xMT. Let's have it. The MMC3316xMT is a complete 3-axis magnetic sensor with on-chip signal processing and integrated I2C bus. The device can be connected directly to a microprocessor, eliminating the need for A to D converters or timing resources. It can measure magnetic fields with a full-scale range of plus minus 16 Gauss with 2 milligauss per LSB resolution and 2 milligauss RMS noise, enabling heading accuracies of less than 1 degree in electronic compass applications. Due to these good features, it's applicable in a lot features like electronic compass, GPS navigation assist, positioning, sensing. This sensor is available and can be purchased from the website controleverything.com as you can see, and you can have the code from resource tab, and you can download this as a zip file from this website. You can also have the code and you can download it from github.com, and the repository there is Control Everything Community. In the end, I just want to make it clear that in case of any part where you have some queries, you can reach us on controleverything.com, and you can post your comments on the community page of this website like this. Now for articles and blogs which are relevant to this sensor or video, you can have a look over on instructables.com, and to subscribe more video tutorials just like this, go to our YouTube channel and follow them and subscribe it. In the end, I hope you enjoyed this video and you liked it. So thanks a lot for watching.